રવિ, કોઈને યુટ્યુબ લાઈવ દેખાય છે અત્યારે?
મેં યુટ્યુબ ની લિંક ખોલી છે.
વિલ યુઝ ઇટ.
અત્યારે આપણે લાઈવ
I think gestures will be good up and down.
maybe now. Yes, so I think we are live
Ravi,
now.
I don't see. Okay, cool. I think gestures will be good up and down.
Maybe yeah. Yes.
Ravi, I don't see. Okay. Yeah.
રવિ એવી કમેન્ટ કરીએ 15 મિનિટમાં પાછા એમ એવું એટલે 15 મિનિટ સુધી હજી પાછું પોઝ થશે. રવિ એવી કમેન્ટ કરીએ 15 મિનિટમાં પાછા એમ. એટલે હજી પાછું પોઝ થશે. રવિ એવી કમેન્ટ કરીએ 15 મિનિટમાં પાછા એમ. હજી પાછું પોઝ થશે.
Hi guys, are we audible now? All right. Looks we are fine. We are good to go.
Cool. Hi guys, hope we are audible and we are visible right now. Thank you for joining with us and thank you for bearing all the technical difficulties we faced. Here we have joined today, to discuss all the career opportunities that are available in IT and semiconductor industries. I would request you all to please keep a paper and pen with you so that you can note down all the, we are all from various domains, so we would be speaking some words which are either new to you or you would be interested in but don't know how to, go ahead and research for that. So just note it down, whatever you like and what are your interests in. Second thing is, during the session, we would be taking a note on all the questions that you post in the chat session. Please post them with the hashtag QA. We have already taken care of all the questions from all those who have registered, but we would also like to answer some of them from YouTube chat session after we talk. So that would be that last 10 minutes. So let's start. I would start with the introduction of myself. I'm Mansi Masrani. I completed my bachelor's in EC from GC Rajkot in 2013. After that, I gave GATE examination. From there, I got my master's from VLSI from Nirma, and then I got internship into Intel. And it's been 5 years, and I am working as an associate design engineer at Intel, and I have been designing CPU cores. Over to Harsh. Harsh.
Thank you. Hi guys, I am Harsh Kotak. I was also part of GEC and I passed out in 2013 from EC. After that, I pursued masters in embedded systems from Nirma University, and later I got internship, and my first job was with Intel. And currently, I'm working with Apple, and it's going good. Welcome to the stream, and sorry for the delay. Lesson number 1: Murphy's law. Whatever can go wrong goes wrong. Sorry for that. Over to Paris.
Hey guys, I hope I'm loud and clear to everyone. So I also belong to the same batch of 2013 as my friends belong to, and we are here today to give you guidance on what could be the possible paths of IT and semiconductors that you can take after your bachelor's. So I completed my I completed 2 government jobs before I entered into IT. I started with IBM as an automation engineer, and I currently am working with Accenture in the same domain. And we will go through that in the later point of the session. So over to Sagar.
Thanks, Paras. Good evening, everyone. My name is Sagar Karia. I am working as a lead member technical staff in Mentor Graphics from last 4 years. I am of the same batch as of these guys. And obviously, I will speak about myself in more details during my turn. So over to Shivang.
Hi viewers, hello everyone. I'm Shivang Trivedi. I did my BTech in 2013, where from GC Rajkot. After that, I cleared my GATE examination. After that, I joined IIIT Bangalore, and I studied masters in information and technology. After that, I joined Intel. where I was a software backend developer, and then I switched to VMware, and currently I'm doing a job in backend development role in over to Pratik.
Hello everyone, hello viewers. So my name is Pratik Bhatt, and I also passed out from the GECR in the 2013. And after that, I have pursued advanced embedded course in one of the good institute. We will tell you about that later. Currently, I have started my journey with a small startup, and currently I am working in the Western Digital. So that's all. I will tell about myself later, and over to Jaspal now.
Hello everyone, very good evening. Sorry for all the technical mishap. Well, I am Jaspal Singh, and we all are from the same batch. I have been working in this IT industry from last more than 5 years. I have been into the multiple companies, and right now I am a part of Continental Automotive. I work into the department of advanced driving assistance systems. We are talking to you people who are students, who have some ambitions, who want to get into the industry the way we had, but being into the college, what and all things you know about the industry. So that's of the prime importance actually. So I'm asking you a question actually. So being in the college, how much an average student or any student knows about the industry, insights of the industry, what it demands, what it takes, and how should be the candidate, what and all skills are actually justifiable for the interview? I guess it would be 20%, 25% on average for everybody, right? Or less. See, talking about myself, just think me of one of the student, because I have been also into the college, and specifically talking about the GEC, you can think me of your buddy, your friend, with whom you roam every day during your college days, and just think of it, how much knowledge you have about the industry. Frankly speaking, when I was in my college, till the last day of college, I only had 5% of the knowledge about the industry. So that's really lagging behind. Something which is going wrong. In today's era, when the world is moving very fast, and being a student, if we lack the information, which what industry seeks from a candidate, is if it's only a 5%, then somewhere we are lagging behind. So that's why this session is quite crucial. And I assure you, there are a lot of things to take away. In a college, typically, what are our goals, or what we look at actually? Just to clear the exams for more than 50% of people. There are few studious people who want to top in their classes, in their departments, in the college. That's good. You should have some enthusiasm. Enthusiasm for what? Suppose I talk about the academic marks, academic scores. Yeah, it's good to have good academic scores, but it's at the same time, it is also important to be connected with the outer world. Why do we study actually? Why do we study? So one day to get a job, to earn, to have the financial security. Yeah, that's our goal, right? So we should be thinking in that area also. So any energy, any enthusiasm, or any sort of thing, if it is not translated into a job or a successful career, then we should be thinking in that area. So talking about particularly about the IT or the semiconductor industry, there is a considerable amount of space in this industry which can accommodate you. Nothing is so difficult, nothing is so far. It's just you have to be prepared. So now talking about myself, actually, I passed out in the year of 2013. Typical I come from a typical business family. Okay, so nowhere being a Gujarati and coming from a business family, and although I had a good score, like considerably good score, the CGPA after I passed out, I never thought of doing a job actually. I was just relaxing. I was just I didn't have any clarity. So slowly and slowly the time passed away. I was I was actually I got added to our own business, and somewhere I also associated myself with some bigger manufacturing units. Knowing them, I passed enough of time like this. So one day I thought like I am an engineer and I had some interest in technical field. So why not to explore that area? Still, being in Gujarat, we didn't know how the IT industries and what the IT world does. So some from somewhere I got to know that there is one training institute in Bangalore. So that, and we got just review about the two things, that there is one training institute on embedded systems. By listening that, the any EC engineer would be happy that if I can join the institute. And the reviews were that they also provide good placement assistance. So just by thinking these two things, me and two of my classmates, we thought like, why not to join? So we just gave an entrance exam, which is conducted in the Ahmedabad. We cleared that and we directly moved to the Bengaluru. And from there, our journey started. We got all the essential skills and we became eligible for the interview, and we were quite good to justify that. So, and today now you can see like we have a successful place in this industry. Now we know this industry. We are serving well in this industry. So what I mean to say is we had only two pieces of information. The one is that the institute is good, and another is the training is good and they provide good placement assistance. And based on that, we just went to Bangalore and we started. But now in this session, you will get immense of knowledge, immense of takeaways. So just be attentive, be in this session till last, and definitely you can shine more than us. Okay. Now over to my other colleagues. They can take away.
Hi. So let's start our session with what are the multiple paths available after doing your bachelor's. So our main aim here is to see how we can find a place in the IT or semiconductor industry. So the first thing is if you don't want any further studies or any other training and you're just looking for a new job, and if you find one, lucky enough, straightforward path, you go for the job, you start your career there. But there are other paths available as well. So one of them is to pursue your master's. And pursuing your master's gives you different opportunities, different outlook as well. And it helps you a lot because you'll be going out in a different college, maybe, and you should make sure in which college you take your master's program. And it offers you to have a specialization in a particular subject. So it is always a good path to opt for masters. And another good thing from the masters is if you opt for a very good college, you can get placements for the internships and maybe for the full-time job opportunities as well from the college placement itself. And in many cases, when you have a 2 years of master's program, 6 months are either 6 months or 1 year is allotted for the internship program. So those are the very good opportunities to enter into the industry. Another part is suppose you are done with your bachelor's and then you say, okay, I want to do master's, but I'm not prepared yet. I want to give a competitive exam, say CAT or say GATE, and you say I'm not prepared enough yet. No problem. You can take a year's drop. You can have a specialized trainings available for this competitive exams. And what you can do is you can take a drop for a year, and you can appear for those exams. And in most of the cases, in many of the cases, it has worked out good for anyone who has taken drop and dedicated a year to study for the admission into the master's program. So that is also another very good opportunity that you can leverage on. Apart from that, okay, if you say, okay, I don't want to drop, I don't want to go for a 2 years master's program, I want to start as soon as possible. What are the options? You still have the options. There are many training institutes available. Like there's a CREAC for embedded program, there's a Maven for VLSI. So based on your field of interest, based on where you want to go further, you have different options available to take trainings. And they have different trainings as well: 6 months training, 1 year training, and you can opt for that. And they also provide you the help with the placements in different companies as well. So that is also a very good option to have. And those are equally good trainings if you don't want to give 2 years to the masters. Okay, then comes like, okay, you say, no, I'm happy with what I studied. I want to just start my career. I'm not able to find a job. What should I do? The simple answer is try to get internships available. So what internships help you is you're not actually full-time employee, but you get a flavor of how the industry is working, how the company is working, how your team is working, how you start working into the real world. So it gives you that flavor, and it always helps you to understand the working of the whole ecosystem here. And the other question might be, how do I get the internship? So again, there are multiple online platforms available now, like Internshala, which can help you get your internships. And if not that, then you can always look over the job profiles available on LinkedIn. It's not only for the jobs; you will also get openings available for the internships on LinkedIn as well. So that is also another thing. And if you say, okay, I want to do a little more on the coding part, I don't want to go to an institute and do my internship. There's one more option available of, say, boot camps or say summer of code. So Google has another program called Google Summer of Code, in which you can do. You will be associated with the Google, but you can be working from your home. You don't have to actually go to the office, but whatever you work on will be monitored and will be reviewed by one of the bidders there, and that way you can actually have a flavor of how these big companies are working. So there are multiple options available. So you don't limit yourself like, okay, after my bachelor's, this is only way or that is only way. There are multiple options available. Keep open to all of them. Think about it, what you want to do, pursue in future. And it is not that one is a good path, another is bad one, or say not so good. These are all the path. There's no limitation to where it can lead to. Today, if you see all the panelists, most of them, having different paths. They have come from different paths, but you can lead to the same position by coming from different ways. So don't limit yourself. Don't think this is good, this is bad. Keep your mind open. Explore all possible options, and you will be you can end up in a very good position sooner or later. This is all about what our paths you can choose after bachelor's. Another thing that we are going to discuss today is about more domain-specific things that are related to VLSI embedded and the IT world. So the flow we are going to adapt here is the actual flow that is used in the product development. So first, the products are developed from scratch from the hardware point of view. So we are going to talk about how the VLSI is working, how the design works, how the verification works. Then we are going to switch to the embedded part, which is like once your hardware is ready, you need the embedded software on top of that, and how you're going to work. How can you get your career started into that? So we'll be talking a lot on that as well. And then we'll be switching to the IT, which is like independent of the hardware, but that is one of the most, which has the widest scope right now to work on. So we'll be covering that as well. So without any further delay, let us start with the VLSI part. We have Sagar and Mansi with us, those who have been working in VLSI from the beginning of their career. And let's hear from them what they have to say. I would request Sagar to share your insights on the same.
Thanks, Harsh. Thank you very much. To start off with, I was just reviewing the registration link and the registration Excel sheet, where I was seeing a lot of questions on VLSI. So what I have decided is that I'll go and talk more about what exactly the VLSI domain is like, and what are the sub parts or the expertise level you require to get in as a fresher from the GEC. So just before starting that, I would just brief about myself more. So I was like a curious kid, like all of you guys, those who are in the EC industry. I was in the sixth semester in 2012, where I didn't know like where my career path was. But then I was going through the digital design and the Verilog basics, and that actually clicked me. Like that actually get me going, and I found that this is my interest. I was just writing a flip-flop design. I was just doing a K-map, and that actually clicked me. Okay, that this is what I am liking it. So from there, I actually started learning more and more about the Verilog and the basic of the digital design, flip-flops, K-maps, whatever you say, which comes in the basics of the digital design. But I was of those kinds who never wanted to do master. So as Hers mentioned, like there are the guys who without any masters can enter into the VLSI field. So I am one of those guys. So I then searched and found that okay, how to get into the VLSI industry. Although though I didn't wanted to do any masters or pursue any further studies or go to outside India and join any VLSI course. So what I did was I looked around. I make my network through LinkedIn. I contacted various industry people who were there in the VLSI industry through LinkedIn, and then talked with them and found that in India, most 80% of the jobs are from the digital verification side. So that's how I got okay that I need to go to Bangalore and I need to start having a training there. So that's how I started my journey. Before I move on to more about my journey and how I reached here, let me talk more about the VLSI domain, what exactly it is, and what are the basic building blocks of that. So VLSI is nothing but a very large scale integration. So it's just like you are making a chip, and it's similar to like making a house where you require a lot of engineers at a various stages of making a chip to build a basic chip. You I will talk about the entire flow in a very short words. Building a chip is nothing but you start with the chip specification. You have what you need. What are the basic blocks you require? What are the gates you require? You start with that. Okay, you have some specification. Okay, that I want to have a CPU, I want to have a memory, and I want to have an interaction between them. You start with that. It's similarly you are just taking a piece of paper and writing on that. Then you move and code them in a Verilog. Okay, that is called an RTL, register transfer logic. You code the entire design which is in your mind, the entire architecture which is in your mind, into a software language called as Verilog or VADL, which you guys might already be studying, and you guys might already be aware of that. So you code that. Then it comes that okay, whatever you have coded, whatever you have thought of, you need to test it. That okay, you are thinking in right terms. So that is the next step. You go and verify it. You write the test bench over your RTL, and you verify the entire design using the verification tools. Then next comes you convert your entire hardware language or the entire RTL into a gate level. Okay, so you are now you can think of whatever the gates you are studying, AND gates, NOR gates. Your entire design ultimately will be folded into the gates. You do that is called as gate level gate level design and verification. And then what it comes is the layout or your entire netlist will be converted into a layout, which obviously my friend Mansi will be covering in the next a few minutes. That is kind of a very simple or the basic understanding of the VLSI domain which I am talking about. So for each of these domain which I talked about will require a different kind of expertise. So there are two basic division in the VLSI. One is the front end and one is the back end. So what you code, initial part of the code which I talked about, like RTL coding and verification, is just called as the front end stuff. And when you go to the layout, where your entire chip will be realized into your architecture, where you will do floor planning, place and route, clock tree synthesis, routing, and then at the end you will go to the GDS, which will be your actual chip, which you will give to the factory where they will manufacture the entire chip. So this is the entire flow, and for each level of the ASIC flow, this is called as application specific integrated circuit flow. And for each level, you require a different kind of expertise, and you should be aware that each level has a different job and requires a different expert area. in India, most of the jobs are at the functional verification side, that is the RTL verification side. Uh, 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 so that's how I got into that. That okay, I found that I in India most of the jobs are verification side. So I went to Bangalore. I started my training in Maven Silicon. I learned RTL design and verification. There I like I then I learned the system verilog and UM, which is a part of the industry. So that's the problem, right? In college, you don't cover those stuff. You have to fill your gaps, which is not there in the college, and do some kind of training or learn online courses, and then apply for the job. So once I go the training on those topics, then I applied. I got the job in one of the startup in Bengaluru in the verification role. And what I did there, I started working on the Bluetooth protocol verification. So once you enter that, you will start verifying CPUs, processors, the mobile chips, or the different protocols like DDR, or that is the memory which is there inside your laptops, computers. So that's how you will be always related to the hardware which you use actually in your daily life. Okay, so that's how you will be constantly in the touch with the current technology as well as the future technology, which you will be realizing sooner. So I worked. One of my project was on the IoT base, so which is like wearable device and the Bluetooth inside it. So that's how I my interest now has got translated into my daily job. And so most of the people who fear that they can't get the job from the normal college, it's totally wrong. You just need to find the correct path and the way to get into the VLSI field. I was one of those guys who didn't had any idea or any luxury from the seniors where I know how to get into the VLSI industry. But if you guys have any question, you are always free to contact me or Mansi for any questions. So I will now handle over to Mansi, who will obviously talk about the physical design and the entire details on that. Over to Mansi. Thank you.
Thank you, Sagar. So, as he said that I'm working on VLSI design part and I'll be talking about that. So, VLSI design starts the moment when you start writing RTL code. So RTL code is nothing but a specification, as Sagar mentioned, the specification based on which you want to, productize your chip. So how well you write your device totally ends up in how well your chip is working. What is the quality targets for it? Normally, if you have heard people say that if you write a code in less number of lines, it's good. It's good because it uses less number of operators, which eventually ends up into less number of hardware used and which eventually saves area. So that is RTL design part of it. After RTL design, RTL verification comes, which is like, as Sagar mentioned, it's 70% part of industry. I just saw in the chat session, somebody asked that where are the more opportunities, either it's back end or front end. So I would say in front end, there are more opportunities on verification side, where you actually verify the RTL which is written, and you write the test benches to make sure that the RTL, the code which is written, is bug free. And if you come to a backend side, you get more opportunities to work on design part of it. Now, let's say the RTL is ready, it's verified. Now, for one RTL, there will be many circuit implementations. So, which circuit to choose? That also depends on what kind of quality are you targeting in your chip. If you are targeting for performance, there is a different kind of circuit implementation. If you are targeting for power, then there is different kind of circuit implementation. Both of this has different teams working on it. So whatever stages I keep on going through, they are all big subdomains of VLSI, and not single person, but teams work on it. So let's say we chose one RTL specification, we decided which circuit to go on based on the quality targets. Then the journey starts on physical design. We take a circuit and we go through so many stages that we get until we get the layout in our hand. Okay, and these stages are something like floor planning and placement. You decide how to place, different parts of design into one block. Then you go for the clock designing. How do you want to, route your clock? It should not degrade. Let's say if your chip is specifying 2.7 gigahertz, your chip should work on that. So that, and then you go with the layout. Once the layout is ready, it is actually the mask, which is used for silicon etching purpose. And then comes the hardware. So this layout goes to the fabrication unit. This also is a big domain in VLSI. You do not really get directly into that, but over the period of years, if you have worked on design part of it, and if you are very closely interested in device physics, fabrication is like very good opportunity to work on. And we in India do not have VLSI labs or fabrication units, but yeah, abroad in US and Canada and everywhere else, there are big fabrication units and you can go there and work on. Let's say our chip is ready. The silicon wafer is out with the design. Then it comes back to us, to the designers, and then there is one separate team which works on post-silicon validation. We call it post-silicon validation because once the chip comes, we actually have to test it that whatever quality targets we set, it's actually working on that or not. Whether the power which we have set, is it actually working on that? The frequency, is it deteriorating? Let's say, what's the yield? If in a wafer, let's say I'm able to manufacture 12 chips, then are actually 12 of them working or 4 of them are not working? So that is called post-silicon validation. Now, in parallel to all the stages, one team works as an integration. That integration is nothing but a team which keeps a check on all these quality parameters. Okay. Now let's say I am a designer. I am working on a one block of chip. So I know in and out of that design. Correct. But the integration owner has different, teams. Let's say one team works and it keeps a check on power. Then he knows that my design has to be meant and designed in such a way that power targets are met. The other team works on area. The other team works on timing. Okay. So me as a designer gets to work on one block at a time, but I know in and out of that design. Whereas the integration owner works on different designs at one point of time. So he doesn't know in and out of the design, but he totally knows that if he gets different designs to work on, how to set up power targets for them and how to keep a check on them. Now, I'll proceed with the VLSI flow, but I'll also start taking questions from the registrations so that along with the questions, I give you the knowledge. So there was one question from Jaideep who asked about how to combine VLSI and IT. I would say that they are not really interconnected. VLSI is totally hardware part of any system, whereas IT is totally application layer part. But if you are talking with respect to coding, then VLSI is not free from coding. Whatever we design is with the help of design tools. So there are separate companies who are solely working on designing tools for us. And they are called design automation engineers. Okay. In fact, even designers like me, we every day in day-to-day life to ease out our work, to complete a job very quickly instead of doing manually things, to complete a setup, to write a flow or to change a flow or something. Even I in a day-to-day life use Perl as a script. Okay, so there are 3 scripts which VLSI folks use. One is TCL. Tickle is used for VLSI CAD tools. Second is Perl. Very easy to learn, but very vastly used in VLSI. It's very quick. Then the third is shell scripting. Shell scripting is must. The moment you are there working on Linux, you should know shell scripting. So these 3 are there. Okay. Then Asia had asked a question about why choose VLSI. Okay. Choosing a career, it's actually individual interest based, but I would tell you why I chose VLSI. It really fascinated me when I see that whatever I have designed is there really live working hardware in my hands. So that's why I chose VLSI. It's really amazing to know. Now, on top of this, VLSI also gives you an opportunity to work on various platforms. As I said, designing, testing, you can work on fabricating, and you can also work on automation, that is scripting. So many different platforms to work on. Also, there is no denying in that it's one of, VLSI design and verification are well-paid jobs. Why not choose it? Okay. Now, Jalpit has asked why the semiconductor industries do not choose freshers. Okay. To this, I have two answers. One, you are really, really right about that semiconductor industries go for campus placements to, specific universities. That is because those universities have very targeted course structure for VLSI. Okay. And they make sure they keep on upgrading those courses. Second thing is they really don't, companies really don't choose freshers because me as a fresher, I would be keen to learn, but I would be really not knowing that if I did a one silly mistake, that can cost $1 billion to a company. The product cycle is big. The product, even a single chip costs $25,000. So that is huge. A single mistake in that can cost $1 million to companies. Also, I understand that it's very hard to get the knowledge on VLSI if you are not going for masters. So what I would say is, if you are really interested in that, and if you are not going for masters, please choose a proper training center and get yourself properly trained for VLSI. Okay. And let's say, even if you are not willing to do that, or you don't have time to do that, and you really want to quickly apply for jobs, then at least go for online courses. There are very good courses available online on Udemy. Once you complete that, get the certification, list it out on resume. That will definitely stand you out in the, when you apply for jobs. Okay. Vaibhav and Yashwant asked about what is the basic knowledge required for interview in VLSI. Okay. One answer, basics of CMOS, basics of CMOS, basics of CMOS. You have to know the CMOS at device level. You cannot just say that, okay, I know the saturation current equations, so it's cool, I know everything. No. Do you know how CMOS works in advanced conditions? You should know all the conditions about that. Know it at the device physics levels. Just get into it. On top of that, VHDL and Verilog coding is must. Okay. Now, if you have some knowledge on microprocessor architectures and assembly language, that is a plus. And Perl and TCL and shell scripting is a big plus that will definitely land you a job. Okay. Shivam asked about what is TFT. TFT is designed for testability. In a chip, whatever chip you pick up, let's say it's CPU, along with the core design, we actually put a test design along with it. That is because when the wafer is ready, the chip is ready, and it comes out, you can actually control the inputs and check your outputs and make sure that your design is working properly. Okay. Last question, I think. Surendra, he has asked that it's an end of Moore's law. What's next? Okay. Surendra, as far as I know, it's not the end yet. I think we have years to go for that, at least not in distinct future. But if you really look over the periods of years in VLSI, we have really shrunk our technology, but we have not really shrunk our architecture. This is the time. This is the time where VLSI industries would start looking into, shrinking the architecture part of it. If you know what I'm talking about, then this is like the FET is now turned into FinFET, that is 3D architecture. The same way we are now looking at packaging them 3D wise. So it's called 3D stacking. So there are so many other architectural opportunities. Other than that, instead of using silicon, we will be able to use other materials also. These are all into research right now, and it's not going to take long enough for them to come out in reality. So VLSI industry is good to go for years. Okay, so I think, more than that, if you guys are really interested in VLSI and if you want to know, in details about everything, we are conducting regular webinars on VLSI domain. You can always join in. Contact your, professors and join in there. So that was all from my side. And this is all the hardware part of a product. Now, having said that, I would like Harsh to tell us more about software embedded film. And Harsh, can you please elaborate also on your work profile and relevant career path? Thank you.
Thank you, Mansi. That was a detailed explanation. Thanks a lot. So now coming back to the embedded systems domain. So embedded, as guys from the electronics would already be knowing, it's a closely linked combination of hardware and software. And the way it works is, if you want a particular hardware to behave in a certain way, you have to program it for that one. So this is actually a kind of a huge field, and a lot of opportunities are available in this field. When you talk about different industries that are working on the highest level of embedded system quality that is required is in aerospace and defense. So those are the main fields when you talk about the IT industry. When you talk about the semiconductor industry, uh, embedded systems expertise is required when developing device drivers and firmwares, which Pratik is going to elaborate on after me. So those are the main things that are available in embedded systems. But what I'm going to talk about is the software IPs that are being developed. So what do you mean by software IP development? So it is specific to a technology that is being developed by a particular company. It's not an open source, and you cannot find a lot of details on online or anywhere else. It's specific to the company, and it's called as the intellectual property. And when you actually try to dig into that, you will understand there's a lot of complexities available. I mean, you will have maybe protocol available, maybe you will have some basic understanding of how the system is available. But once you start working on it, you will have a specific domain related knowledge once you get onto it. Apart from that, what happens is, so suppose right now I'm working on the GPS technology. All the public information that is available online is how the satellites are transmitting their signals, but you don't know how to get your position from that. So those kind of things are the IPs which we will learn about, and when you'll develop when you start working and into a company, or maybe if you try to do something on your own as well. In the same way, there are multiple other protocols available, like when you say Bluetooth or say Wi-Fi, you have set protocols available. Like this is how the things will work. But at the same time, it is not, the implementation differs from company to company. So those are also the IPs specific to the companies, and will be different when you talk about different companies. Implementation and power and performance and all that stuff will matter. Another good thing about this is that you will have the opportunities to have your patents possible to. You will have a lot of opportunities to file your patents, because this is not an open information. There's very limited knowledge available outside your domain. You will be the expert in that, and you will have chances to file a patent based on your, even for the smallest improvement that you can do, will be given an opportunity to file a patent. And if you get a name on your patent, it looks very good on your resume and very good on your profile. So that's a very good opportunity that you can leverage in this domain. Also, when you talk about embedded programming, you're talking more about programming related to the hardware. You're not talking about how the applications would work, but you are talking about how the hardware should behave in particular scenario. So that is always good to understand. And it will require a certain level of knowledge about the hardware, but it's not like you need to know the complete hardware, but you need to know what triggers what. So that is very important to understand. And it's not that it's only limited to the guys who are into the electronics. We even have people working from the computers engineering background, or working with us and developing this embedded software, because it's not that difficult to get understanding of how the hardware behavior is, but it's good to know. But it's not a restriction or not a limitation that limits you to for working in the embedded systems. Also, when you talk about the IP development, the level of expertise that is required it's unprecedented. So what happens is, when you start working on it and once you gain your expertise, there will be very few people in the industry who will be knowing that stuff in depth as you will be knowing. So if you work in a particular IP for a very long time, there are good chances that you will be in a demand for in the long run. And always good to have that in-depth knowledge. You'll be happy to see. Today, if I talk about something that I've worked on, I'll be happy to see that, okay, I see so many smartphones working in around me, and a lot of them are working on the files that I have worked on. It runs on the software that I have worked on. So it feels good in that way. And apart from that, we'll have reverse drivers and firmware and other part of the board bring up. that Pratik can explain in a lot more detail. So Pratik, can you please share your share your experience?
Okay, thank you very much, Harsh, for explaining the IP specific domain. So I will give some brief about myself. So as I mentioned, I have also done my after passing the graduation, I have done the Vector Institute embedded training, and then I have started working in the one of the startup company. So like I did not started with the MNC, but okay, working in the startup also I have learned so many things, and from there to till I joined the WD, I was working on the device driver, the board building up part. So I'm going to elaborate. I'm going to explain you guys what is the basic of the device driver and what is the usage of and what is the career growth in that. So let's start with that. So first question, all of you, if nobody had heard the name the device driver. So what is the device driver? So device driver is the nothing. It is give the capability of your computer operating system or either your application to communicate the low level hardware. So simple example, we can take, you want to read something from the, you want to read something from the EEPROM connected to the board. So that you can do through the device driver. So there are multiple type of device drivers, but to give you the just overall idea, if anyone knows not knowing, so you can think of that you have a laptop, and when you plug in any USB stick, there is some pop-up like driver installing the device or installing the driver. So that is the part of code which is actually installing in main in your computer, which is able make you your computer operating system your file explorer to access that particular USB device. So that is the one kind of the device driver. Another kind of device drivers are there like which help boards to boot up. Like the processor only can't boot by itself. It need to communicate with some of the peripherals. Like one peripheral, you can give the example of RAM. So to communicate with that RAM device and everything, some of the processor internal module also it required the device driver. So this is also one kind of device driver. So now in the controller way, if you want to think about like in the very basic way. So if you take the example of the 8051 controller, and in the 8051 controller, if anybody have done the programming for the LCD initialization or printing something on the LCD. So what you do actually, so you just make one function which do all the like prerequisites before sending any character or anything to the LCD, and all that taken care all that part of initialization of LCD you will taken care in that particular function. Now from the main program you just call the API like print ABCD name, print XYZ. So this is also a kind of device driver. So device driver is which would drive the device, and in another way you can think it will initialize the device in the boot up also. So you can think in this ways. And how okay, so you are talking about the devices could be the peripheral also which is connected to the processor. So how the processor communicate with these peripherals? Okay, so mainly in the embedded system, 3 or 4 protocol use like UART, SPI, I2C, and the PCI. So these 4 are the main protocol which is vastly used in the embedded system. And if you got the grip on this protocol, and if you know the basics of this protocol and in depth of this protocol, it is very good for you, all of you, to start with the working in the device driver, and it will help you to get the job also. Okay, then another thing I want to highlight on the device driver, the device drivers are very specific. It is not like the one code you have written for the particular device will directly work onto the another device. So one thing you have to keep in mind when you start working, when you want to work in the device driver, when you start working on the device driver, you have to understand the device part also. Like you need to go through that specific device data sheets, which has sometimes in the multiple pages, in thousands of pages. So you have to go through that also. You need to pick the part which you want to do from that device data set, and you need to learn about the hardware also. So this is about the what is the device basic of the device driver. The next part I want to cover, it's like what is the importance of the device driver in the embedded field. So you can think of like nowadays all the device starting from the small bulb to the big servers are getting smarter and increasing in manifold. Okay, so more the device and the application are get smarter, the requirement for accessing them to hardware and advanced hardware feature are getting more complex. So device in the today's world, the advanced device driver are providing the accessibility and the APIs to access this hardware to the application developer without much worrying about that low level devices. So that is the one important of this thing. Then next part, I want to emphasize on the software skills, which is more very important for the device driver development. So first, as I told previously, all that 4 protocols, SPI, UART, I2C, all that as mandatory and must to have. And then in the software skill side, language you can pick any C or C++, but the pointer concept, the structure concept, the bit operation concept, how you can optimize all of your operation in the single line, 10 line operation in the single line. So all that kind of thing. So that is the very helpful for you guys to work in this domain. Okay, so next part, what is the advantage of working in this field, embedded field of the device driver? So device driver mostly related to the kernel. So as if maybe some of you don't know about the kernel, so you can Google it. It's a very vast domain and you will get a lot of information from the kernel.org, which is the main contribution site. So it is the open source, and since the code is open source, you will get a lot of support from there. And you will get to know what is the quality of code you need to write to work in the device driver. There are some standards. If you write a code and if you don't follow that standard, you are not able to contribute in the open source. So that is also one advantage. And another advantage working in the embedded device driver field is like you can start from your college itself. Like there are very cheap development boards like the BeagleBone, the Raspberry Pi are available in the market. So maybe most of you guys think about those boards are for application development. Some people are doing the project on Python on that. But if you go to the website of them, they are also improving the kernel part, like which is they are using for their processor, and they keep on asking. Like there are on the community there are always some questions and difficulties are there, and people used to solve them and post in the open source, and that will help them to grow in career and in their resume also. Okay, so that's all from the device driver. I don't want to cover it more. You guys can ask me question in the comment or come back to me. So next part, I want to small thing I want to talk about the board bring ups. So what is this board bring up? So generally in the most of the companies in the startups, you will see this terminology used fast. So what happened in the now small startups or the person who want to be entrepreneur, and they used to like think some idea, and to develop that idea they have to make some board, like they have to make some device if they want to do some their idea is related to some physical device. Okay, so what they do, okay, like they take some ABCD processor, they take their development board and they modified it according to that requirement. They reduce that size, they reduce their cost, and they put the devices which is relevant to them. So what they do after making this board, after hardware people make the circuit diagram, we printed the circuit board, you need to verify it. Like when it's shipped out from the manufacturing unit, you need to boot that processor first time. You need to initialize all the peripheral. You need to check each and every path of signal, like it's working fine. So that is the board bring up procedure actually. So in this process, you will like learn how to work with the CRO, how to probe with the signals. I can give my idea. I was working on one of the HDMI display hardware, and like we are not getting the display, and we used to probe the actual HDMI signal, and we learn how it is working. So that's all on your interest actually. So that's all from the board bring up part. And I want to discuss about now lastly what is the growth in this embedded software. So you just think how many application developer currently in the world, and how many device driver developers you heard in the world. Okay, so there are very less. There are many less, and the growth is very well. The companies like Nvidia, Intel, Qualcomm, ARM, AMD, which these are the companies which closely work with the device drivers and the device drivers. Okay, So you can explore the growth, explore your path in those company. You can explore path in this particular domain. Okay, so that's all from my side for the device driver embedded domain. So now, guys, we have seen is the software. Hello. Sorry, guys, for the interrupt.
Hello, viewers. Mansi, Harsh, very good in random embedded field. So I'm pretty sure that these things won't work until the IT guy like us will code on it. So I'm here to give you a brief insight on the IT industries that currently is, and what is the situation of the IT industries, what are the domain of the IT industries, what are the requirements and the projects that we do. Firstly, I would like to introduce myself. I'm currently working in the VMware as a software backend developer. Mostly I work on the they do in the software development. So let's start with the software development life cycle. So what should be the enterprise level software development life cycle? What should it include? How much it should have? Let's start from the beginning. So once project on your head, let's say it can be web, it can be Android development, it can be iOS development, it can be any kernel device, or it can be anything. So first phase of the product will be a project requirement gathering. So once you have the project requirements, then you will understand the requirement. What is the core requirement of the device? What will the components that I will need for this particular project? Soon after that, what you have to do is you need the use cases of it. You have to document those things. You have to create the sequence diagrams of it. You have to do all document on the project that will help you going forward. So tools which are for sequence diagram and the use case designings are Microsoft Visio, and if you see on the online, those are draw.io, things like that. So once you have the sequence diagram of the products, once you have the requirements, what you will do? You will design the product. What you will understand that this system needs this front end, back end, DB, or a cache or a Kafka queuing mechanism and whatnot. So you will decide that that it will have, and then you will design in a such way that all interact properly. The architect of the design is very important. Otherwise, issues going forward. So first you decide the architect of the design. So currently the world is moving towards microservices. Monolith is no longer. Microservices helps in scaling up the backend and scaling up DB clusters and everything. Microservices are good to go, and we all should use the microservice. So microservice based architecture. What is microservices? So microservice is part of a service which will be handed over to that particular service. Let's say you are going to Flipkart. So Flipkart will have a profile management on its other service. Flipkart will have its products on the other service. Flipkart will have its recommendation on the other service. All the ML and everything is running on the other service. And all the microservice will gather the data and put the data in front of you when you click the flipkart.in.com. Once you have finished the product design, once you are done with the product design and you know that what component is going to talk to what and how the request and response and everything is happening, the third part will be schema design. How DB will handle that. How the DB design should be. Is it should be SQL? Part of it should be part of part of it should be SQL. You have a hibernation of both. You need a Redis cache or not. Your profile should be in Redis or not. The latest products which we are putting and people are searching more and more on about that. Should you put it in Redis cache or not? Things like that, you will question your product, and the product, based on the product requirements, you decide that what is the requirement and what you should do. So after that the coding starts. So coding is the core part of it. You have to be specific about your design, how you are going to design the code. Design should be modern enough. It should be scalable in the long term. It should be understandable in the long term. You may end up doing lot of complex code, but that cannot be understood by your friend or someone. So that can be also a disaster in some case. So these are the coding practices you should follow. So, and the coding should be as simple as you like. So when you are coding, you make it simple and make it modular so that everyone can understand. There are few technologies I'm going to talk about regarding the coding and the parts of it where we should use it. So let's say front end. So front end, you always choose the best in the market technology. So in front end now there is React and Angular. Go for it, and you should learn the React and Angular. Not many tutorials and videos are available on the YouTube and all the other sites. You can learn it. If you will create only one minor project and host it somewhere, that will give you enough knowledge of how the front end or back end will work. So the next is the back end. Based on your language skill, you choose your platform. If you are good in Java, go for Spring Boot. If you're good in Python, go for Flask, Django, Tornado. There are other languages also for particular backend services. Golang and Ruby on Rails are there. You can go for those languages as well. After that, DB. So DB cluster is most important part, because you don't want the data cost to you need particular data when you want to solve the request. So based on your requirement, you can go with the SQL relational DB, which will be good in market right now. It's Postgres. You can choose NoSQL DBs as well. Mongo, Cassandra are NoSQL DBs. There will be caching layers. If you want to choose the caching layer, is the Redis cluster is well known. It will give you order 1 complexity in the search. So caching layer Redis is very good. Once you are done with the coding, once you have complete product in hand, you can start writing the integration test of it. You can do scale and performance test of it. Then after, you go on and deploy the product. The deployment will take you whether you should do in-house deployment or whether you should do on cloud. In-house will ask you for infrastructure, many VMs, server, power, CPU, and everything. And on other end, you can choose any cloud, AWS, Azure, Google Cloud Platform, and there are many other cloud platforms are also there. But as AWS is well known because its documentation and its serving capabilities. It can serve and it can scale. You can have monitoring system available over there. So you should know the basic skills of the AWS as well, just like EC2 instances, auto scaling groups, load balancers, S3 buckets, what is the AMIs, and things like that. Once you are done with this, you are short of having a resume which is good to go in the market. Because in market, people can ask you any of the question from this much domains. Other domains, this what I told you, the software development life cycle was partly relatable to the web development or a backend development. Other domains are system firmware development, as Pratik and Harsh mentioned. System firmware development is also very good domain. After that, Android and iOS are also booming domain as of now, because everyone wants their application in hand. Everyone wants their logo in the hand. So that's why everyone is moving to mobile rather than the web applications. Yeah. So third point is, someone has asked that what is how they can combine the embedded and and the IT. So embedded and IT can be combined in the IoT applications. So once you have the firmware on your controller, firmware can talk to cloud. Cloud can reach out to your web application or a mobile application, and all three alongside can work for your application. You can write any tiny applications on the Raspberry Pi, Galileo, Intel Edition board, or Arduino board. You can use any board. You can code on it, and then you can ask that application to talk to the cloud. You can manage the IoT device from the mobile application. And this is the one where if you are in fourth year and want to do some projects, go for it. You take one guy from IT and one guy from EC, and you can combine the team and team up and do it. Other than that, there is a network domain. You can do CCNA, and then you can go for Cisco and other networking companies. Then there is a DevOps and cloud computing. So that let's say these are the DevOps, cloud computing, testing. These are the domains which are less coding required. So let's say you are in computer engineering. After 2 years, you realize that I am very bad at coding. It can happen. It can happen to anyone, and you certainly lose the hope that you will be good in coding. So these are the fields you can target. So testing will require very less coding. DevOps will require certain amount of coding, but it will be very less. You will love it. You will love the power of one command. Or with one command, you will be able to deploy a lot many stuff in the one go. Apart from this domains, there is a very good domain, UX designer, which can wireframe design of how look and feel of the mobile application or the web application. After that, Gaurang has asked us a question that what is data science and how he can proceed in the data science. So data science, data engineering, and machine learning is the booming technology right now, and one should know and one should learn about it. So if you want to start with the data science, you can look into Python, and Python has very good libraries for it. sklearn, pandas are one of them. And if you are starting, you can check your ML models in Auto sklearn and Teapot. The Auto sklearn and Teapot are the libraries which will give you the ML model based on your data set. So that is also very good to know. So how you should proceed in the data science and ML technology. So what you should do is you should go to kaggle.io. You can submit your results. You can submit your identifications, and you can take part of hackathons on that. Once you have 4 to 5 good project, your resume will be good to go in the market. Or you can, if you have some hackathon winning team, or if you have won the awards in the hackathon, then you can put in that in your resume. That will enhance the data science and machine learning skill for you. Or I would still like if you will go for masters in data science and machine learning, because all the big companies like Google, Apple, Microsoft will choose the next interns from this kind of institutes. Yeah. So after this, I would like to consider that how we should go for an IT interview. What should we prepare for an IT interview? So first part is algorithm and data structure. If you are giving an interview for a smaller company, bigger company, no matter what, first round will be algorithm and data structure. There will be a round where your coding skill will get tested. For that, you should start learning from the Geek4Geeks lead code. There is one particular site, Interview Beat. It is well known. You can decide your pace, and based on that, you can code it. Either you can do 2 programs in a day, you can do 1 programs in a day, you can do 3 programs in a week. You can decide your pace, and you can complete your course on the Interview Beat. So that is also very good to have. So, and after that, these are the and once you have learned the programming, you should practice it on the paper and pen, because interviewer will ask you to write the code on the paper and pen. So it is very good. If you are lucky, then they will ask you that pseudocode is fine. But if you are unlucky, they will ask you that you code it in your choice of language. At that time, you should not make any semantic errors. For DS and Algo, I would recommend NPTL. On YouTube, there is videos from NPTL. You can go and check. It's very good. Other subjects, database. You should tackle all the tricky queries. You should learn about normalization. You should know about indexing. For operating system, processing, threading, semaphores, memory allocation, CPU allocation, everything is must. You should not go in an interview without knowing this kind of stuff. For computer networks, OSI layers, HTTP protocols, encryption, decryption, public-private key algorithms, all are necessary. A question can come from any direction. After that, if you are going to further rounds, there will be design pattern questions. So design pattern questions will come from the singleton pattern, strategy pattern, factory pattern, or whatever pattern you have coded or you know. So the interviewer may ask to code that pattern for you. So this was the product development life cycle and interview process for an IT guy. Now I would like to introduce more about how we can scale this product, how we can monitor this product, and how we can deploy this product. Paras will give us some insight on that. Over to you, Paras.
Hey, thank you, Shivang. I hope I'm clear and my audio is also very clear. So, guys, Shivang gave you a very good brief about how the development cycle works in any IT industry, right? And any of the companies in the IT industry. So, what I will take you through is something which follows after the development is completed, right? So, you just can't you can't just develop your code and just expect it to run without any hiccups, right? So, that is where DevOps engineers come into picture. So I'll briefly mention what DevOps means. So this terminology itself, is divided in two forms, right? It's Dev plus Ops. So the developers plus operations. In the traditional IT model, what used to happen is, companies used to have two separate teams: a team of developers and a team of operations guy. So what happened is, there was a gap in between of them, and that led to many of the issues. So what the modern IT model follows is that currently it is expected out of any engineer that he should also have the knowledge of the development side, and also in addition to that, he or she should also have the knowledge on how IT operations work, and how the application would be up and running always without any failure. When I say without any failure, it literally means without any failure, because you would be coming across many such applications which can't go down even for 1 minute. If they go down for 1 minute, it would cost them millions of dollars of loss. So I don't need to elaborate that, because you may already be aware of the use cases of such, like banking applications, like insurance applications. They can't go down even for a minute. That is where I also answer the question why you should choose DevOps as a career. DevOps is a challenging career. It is time bound, because you need to resolve the issues that come to you, at the fastest pace possible. You can't, just juggle around. You have to give the solution to the problem at the immediate point. So, that is how it is a challenging career. And as it is a challenging career, it is also one of the well-paid careers in IT. So, the journey stays similar as, what Shivang discussed in detail regarding the development cycle, right? It starts from the requirement gathering, then you have to go into the development phase, then it goes to the deployment phase, and finally you can call it the maintenance phase. So the cycle also stays similar in the DevOps model also. So I'll talk about in detail what DevOps tool stack looks like. So there are many tools and technologies that are involved in DevOps, and it is expected out of any DevOps engineer that they should have at least the basic knowledge of these tools. So I'll explain what tool is for belonging to which category. So if you are coding, mostly in the DevOps platform, I have seen that you should at least be well versed with Python. Also, you should have very good knowledge of shell scripting. These are the two main. I won't deny that there aren't any other programming languages involved in DevOps, but these are the two major programming languages that most developers use who are working as DevOps engineers. So then comes the source code repositories. So there would be coming. You can consider Git or the use case of Git that is popular, GitHub. Also, you can use SVN. So these are basically the code repositories which allow you to control the versioning of your code. So it is very important that you maintain your code in such a manner that it is easily available across when you are working in a team, right? Because you won't be working alone. You will be working in a team structure, and everyone works on a module or a particular set of problems. Then you will be working along with the team developing certain part of that solution. So that helps to have a common repository for your code where you would be able to version it properly. Then comes the config management part of it. So when I speak about config management, you have developed your code, but you don't know how to develop, apply that code across all the platforms that are available in your, in your for your application, right? You won't be working on one machine. You will be working on, lots of machines when you are working in any normal IT organization. So you have to apply all those changes into all of the machines at the same time, taking care of the availability part, the rollback part where if something doesn't work, then you should be able to roll back that thing. So there comes Puppet Chef. Those are the configuration tools that are available to us. And then Shivang explained it to us, right, about the cloud. So I'll take a minute regarding discussing what the cloud is and why someone should learn cloud, right? So there would be many providers of cloud. So Amazon, Google, Azure, all of them are available. They have best-in-class services available in each one of them. Each one has their own unique features, which addresses industry-specific problems. But I'll just tell you the market figures right now. So around 50% of the industry is in consider it Fortune 500 or total IT industries that are there. 50% of them use AWS. So you can just imagine the magnitude of companies that use AWS and why you should learn cloud. So one of the students asked me this question, that why I should learn cloud, right? So there is a difference. In past, companies used to spend millions of dollars in setting up their infrastructure, buying everything, buying whole of the hardware in their premises, and used to maintain them. Now, what has happened is that the era has come in. We have entered into that age that people don't want to pay for the things that they are not going to use always, right? So you only want to pay what you use. So that is where cloud comes into picture. It gives you the flexibility to, I'll just, trigger an EC2 instance only for the time that I require it. If I don't require it, I'll just, shut it down. So that is the flexibility that cloud provides. So, you only pay for what you use. So, I'll definitely tell, everyone who is, aiming for an IT career, and I won't, differentiate between an electronics guy or a computer guy because the interest can differ. Even if you are into electronics, you may want to go into IT, and vice versa, right? So the thing is that you should know cloud, and for learning AWS, there is one very good site available. Not only AWS, if you want to learn Azure or if you want to learn Google Cloud, you can go to acloud.guru. I'll mention that URL, or someone else will mention that URL into the comments. acloud.guru. You can go to this site and you can register for the course that you need. Okay. So in cloud also there are various domains that are available. You might be a developer, you might be a DevOps engineer, or you might be a solution architect. All those are the career paths that one can choose. Once one person decides that he wants to choose, cloud has this career. So what you can do is that you can go to this site, you can register, and also AWS provides you a 12-month free instance. So you can just go and use that. You try to learn as many services that are there in AWS. I know that there are around 2,000 services that are available on AWS, and I can guarantee you that no single person on the earth would be knowing that all those services. But the thing is that if you know basic services that are there on AWS, you are good to go. So these are the points that I wanted to cover. What are the DevOps tool stacks look like? And addition to that, I wanted to mention something called containers. So containers come into picture to make our work easy. So I'll just give you a brief what container is. So in DevOps, what happens is you want to, let's say an example, you want to set up a web server. Okay. So what you will do in the normal scenario is that you will allocate a VM to that. A VM will have all the resources, computing resources, storage resources, memory resources allocated to it separately. And I'm just running a simple web server. So I don't need all those resources. Instead, what I can do is what are the essential libraries that a web server requires? What are the services that it wants from the OS, right? From the OS layer. So OS layer, kernel layer, whatever services it requires, I will only use that service and I will form a container. So what the container will do, it will act as a web server standalone. Okay, and you can deploy this container over the cloud. So it just imagine that you had had deployed a VM over for a web server and just a 200 MB container for doing the same job for you, acting as the web server. There is a vast difference in that, and that is where Docker containers or any other container provider you can use. So that is also one of the fascinating technologies that that are covered under DevOps. So these are the tool stacks that I wanted to cover. Now I will speak about what I do at Accenture. So I work as an automation engineer at Accenture. So what we do is that we get business applications from various clients, mostly banking clients and insurance clients. And what we do is that we automate those processes. So just consider a loan processing application, right? So what we will do is that a person would be working on that loan processing application manually. What we will do is that we will automate that whole flow, and we will deploy it on the bot so that no manual effort is required. So in a way, we are making IT services independent of manual work. We are trying to automate as many business applications that we can, and we are deploying the same solutions over cloud. So that is what my work profile includes. Moving forward, my advice or my opinion towards the people who are targeting to be and entering the IT field would be, learning specific framework out of any programming language is so important today. You can't just go and target one language. I will learn C. No one can do that. No one can learn a whole programming language by itself, right? You want to learn what are the specific applications or what are the specific frameworks that you want to learn for a programming language, right? So if let's say you want to learn web development, right, and you have chosen that I will work on Python, right? Then you would be choosing the specific framework for that. So you would be choosing like Flask, Django, what Shivang mentioned, right? So for example, if you're working in data science or you're working in machine learning, then you would be working on NumPy, TensorFlow, all those kinds of framework, right? So what I'll just tell all the students that are available in this session, that prioritize your learning on what your interests are. Choose your interests very well beforehand, choose your language beforehand, and then you just try to solve small problems, automate very basic tasks, and try to build small utilities and push them over to Git. Ask your friends, ask your professors, ask your colleagues to review them. They will tell you that what would be the best suitable approach that you can take that further, right? So don't hesitate in learning and showcasing small things, right? So at last I'll just tell one thing that if you are choosing how now the question comes, right, how to choose a particular programming language. Then it comes to the point that what is the best, who is the all rounder. So if you are just considering the analogy, I'll just give you a very simple example. If you are looking for an analogy, right? So right now in the cricketing world, who would be the all rounder, right? So it would be Virat Kohli, right? You would be considering him. He can, play in Test, one day, 2020, all those kind of formats, right? So Python here can be synonymous to what is Virat Kohli in the cricketing world, right? So it can perform in ML, AI, or data science field also. It can also perform in web development also. It can also work on other domains that are there for OS development, kernel side. All those things can also be done on Python. So it is the versatile language that is available in IT. There are also specific frameworks that are available. For example, if you want to work on web development specifically, then you can choose JavaScript. You can work on their specific frameworks that are available, React, Angular, all those were mentioned before. So, if you're working on OS level, kernel level, or device driver, as my friends from the embedded field mentioned, right? So you can choose C there. Or, if you're working into image processing, or if you're working in game development, or, graphics, those kind of things, if you're working on, then you can choose C++. So it's all your choice, but the thing is that your domain and your, interest should be very specifically chosen beforehand. You shouldn't be like juggling around with the ideas that I will choose something which is relevant to the industry. Rather than your choice should be based on your interest. Okay. So, uh, and there are a few futuristic platforms that I want to mention here. I won't take much time. So the point is that if you are looking something for the future, what will be relevant in future, what programming language I should learn for the future, then I think you should go for the Golang. So that is the Go language that is developed by Google. It is backed by Google. It is very good programming language to learn. It has features like multi-threading. It has concurrent execution available better in class than compared to Python even, and compared to Java even. So you can choose that. If you are going into Android development, then I think you should go for Kotlin, which is better than Java, better alternative to Java. It has all the advantages of Java and plus many more features. So you can choose Kotlin there. And regardless of all the languages that I mentioned in the list, right, you should also take care. There are two basic necessities in IT, right? You should know any database, any one good database you should know. Maybe SQL, no SQL database doesn't matter because that depends upon the application, right? So it would be basing what type of data you are dealing with. It might be the structured data, or it might be the unstructured data that you would be dealing with, and based on that you would be choosing the database. But regardless of that, you should know any one database thoroughly, and you should at least know shell scripting, because that is the must. Because in regardless of in any IT environment you would be working on, shell scripting would be a must. So that is pretty much all we wanted to cover in the VLSI domain, as Mansi and Sagar took you through. Embedded domain, Harsh and Pratik gave you the insights on, and the IT sector that me and Shivang are working on. So, we tried to cover, as many points that we wanted to, because due to time constraints, we can't cover everything, but, we tried our best to do that. Now, what I will move over to is I will pass it over to Harsh, and I will ask him that what would be the basic skills. See, the thing is that even if you are working in VLSI or IT domain, doesn't matter. But what are the basic skills that you require today to get into the either of the fields? So over to you, Harsh. Thank you.
Thanks, Faras. So there are a few set of basic requirements that any company would expect for any engineer coming out of the college, and possibly you might not study this in your college. So, for example, scripting language might not be there in your course, but it is very important to learn at least one of the scripting language based on your interest. So if you're opting for, say, VLSI, you need to know Perl, Tickle, TK. If you're working in, if you're planning to work into software, you need to know Python at least. So these are the basic skills that you need to know. Apart from that, you need to know what is how does the Linux basics work. Linux internals understanding is required in any of the field. Even if you're working in VLSI, you need to know some of the Linux internals, Linux command line. So what I would suggest is better you guys install a open source CentOS operating system in your on your laptop, and start using the command line version only. Don't go for the GUI. Start trying to move the files, execute the program, try to open the text file in the Vim editor or any other editors which are like terminal based. So it is important to know those stuff. It will help you in the long term in the industry to get things up and running faster. Apart from that, what you need to know is the Git. So source control mechanism, which is very important and used widely in any of the company that you will go in. So Git is one of the examples. So I would suggest just go to the Google and start learning Git. Just Google out what is Git or maybe SVN. You will be able to find very good resources available in their official websites. You will be able to find many of the YouTube videos available. So you're better to go for that and start learning those things, which again might not be included in your curricular courses, but it's very important to know those stuff. Apart from that, you should all. I mean, when we are preparing to get into the industry and trying to get interviews, we should be very good at aptitude and reasoning part, because those will be included or will be a part of any of your say interview process or any of the screening process that you will go through. And I mean, even if you go for the any competitive exams, it will be always be useful. So no doubt, no other course will include that, but it is good for you to start learning those things, start practicing those kind of problems and small questions, and it will be very helpful to you. Apart from that, I think there are some industrial certifications available. Paras, would you like to give some more details on that?
Uh, sure. Thank you, Harsh. So, as Harsh just, explained, right? So, these are some of the basic skills that you require whenever, you're working in regardless of IT sector or embedded sector or VLSI. It doesn't matter. These are the skills that are must when you enter into the IT field or the semiconductor field. So, the point that I wanted to explain here is that industry certifications are very essential today, especially for students, right? The thing is that no one in the interview panel would know that how much expertise you have over a particular technology, unless and until they test you out in coding, right? But even without doing that, if they have a validation available with them that you are certified on cloud, for example, right? You are AWS certified cloud professional. You are AWS certified DevOps professional or solution architect or something like that. So they get the basic idea that you have, what it takes, to know the cloud, or you would be the fit person to work on the AWS part of their job description, right? So they don't need to ask you, more questions on that thing. And similarly, it applies to other fields also, right? Maybe data analytics, web development, they have their industry specific vendors, right? Who would be giving or, providing certifications for their particular tools or technology, right? So I will insist you guys that you should get certified on the technologies of your interest, because it adds to your profile. But don't blindly just go for certification. I'm just, telling this out that certain people, what they try to do is that if I'm getting this certification just for passing that exam, then it won't add a value to your profile. Rather, I would say take the difficult path. Try to learn everything that is there in that certification, syllabus or whatever it may have. So try to cover that scope and then appear for that certification. And I'll definitely guarantee you that it will add to your profile. You will learn a lot of things while the phase you are choosing to get that particular certification added to your resume. So this is very much important point for students who are just in the entry point of their career. They should definitely look for industry certifications, right? Also coming to the point where you start coding, right? So as we are into a varied audience here, right? So many people would be using different IDEs, right? So they would be using various development environments, or you can call them the code editors, right? So that would be a layman term of saying that where do you code? Then someone asked me, then I would say I would use Vim, right? So that is the tool or the code editor of my choice that I would be working on. So based on your technology, your domain, you would be using certain IDE, right? So I'll encourage you guys that you start using those IDs. You get used to, what would be the basic instructions or basic commands that you can provide to the IDs to get certain things done, right? So it is very, it's not say a must thing, but it is very good to know the shortcuts or shortcuts or the insides of the IDs, right? So certain times it happens that when you are editing a file in Vim, if you have the shortcuts of shortcuts known to you, then you would be able to quickly edit some files and get things done faster than others, right? So it is very helpful when you are applying for certain competitive programming kind of scenarios, right? Where, because time it would be time bound, and if you are if even if you know the solution, and if you are not able to deploy that solution, or if you are not able to write that code within the prescribed that time, then you wouldn't be able to just due to the lack of understanding of that ID, you wouldn't be able to do that. So yeah, these are the pretty much the basic skills that you require for any IT domain or semiconductor domain as such. As Mansi and Sagar already mentioned regarding the Perl and Tickle, that those are the must knows for if you want to move towards the VLSI career path, then you should know Perl and Tickle. So those are the starting points for you. Why we are mentioning these basic skills is because these are the starting points, and you can these are the must knows that you should take into consideration. Yeah. So we covered what are the basic skills. Now I will pass it over to Harsh and Shivang to let us know that what would be the interview, and how to face an interview, and how to build a catchy resume, right? So as a resume is your first point of contact with any person, any recruiter. So they will give you more insights on that. Over to you, Harsh.
All right, thanks, Paras. All right, so let us have a look at. Let us see the hiring process, how it goes. So first, we'll see. First thing you'll have to do is build your network. You will have to contact people in the industry and contact the companies that you want to work in. You'll have to submit your resume there. Your resume needs to be crisp and clear as much as possible, because before you go for the interview, before you appear yourself for any interview in the company, your resume is your whole portfolio. So that has to be very precise, very clear, and very nicely built. And then you will go for the interview process. So I think we are running a little short of time. So what we'll do is we'll try to cover all the things as soon as possible. Let us start with building. How can you build your network? So, Shivang, would you like to add something on that?
Uh, sure, Hers. So, for giving a good interview, or targeting a good company, or targeting a good domain is never easy. You should build your network. You should know the community, and then you can target for that particular job or that particular company. So, I would take a few moments to emphasize on what is needed to have a networking, or how one can go ahead and do the networking for that for particular IT industry. So one thing is must is competitive coding. Competitive coding in nowadays is like must to have for all the IT engineers. You can go on CodeChef, HackerRank, HackerEarth, and you can create your good profile. You can solve daily 1 or 2 questions. You can do puzzles over there. You can answer a few questions. For data science and ML profile, you can go to Kaggle and do some problem solving over there. After that, hackathons are going every day from one other company will host a hackathon, and you can participate in that. It's not tough. You can create one product, you can create one project, one paper, one presentation, and you can apply it to everywhere. You can go for everywhere. You can everywhere, and one of the places will accept it, and you will get a chance to win over there. So this is the thing that you should must have. After that, open source contribution is must needed. Open source contribution is needed because that's how community will know you. That's how community will know that this guy is interested in doing the coding for, let's say, Kubernetes, or let's say for kernel level coding. So for community to know that you are good in that particular domain, you have to start doing open source contribution. Anything. If you have written a small handler, small HTTP request handler, push it to Git, show it to everyone that you have created it. One guy or two guy will use it, and he will be thankful. uh, After that, attend meetups, workshops, anywhere it happens, you attend it for your particular interest and for your particular domain. There are several opportunities to visit several countries also. You can the host will provide you the full grant of it. You can go and enjoy for a week, and you can, alongside that, you can have the workshop and have the meetups, and then you can come back. One such thing just went last week is in Amsterdam. They have hosted a SRE conference, so that was in last week. So things like that will come and go, and you have to catch those things. If you are good in your community, people will grant you the money to come and just enjoy. So after that, masters in tier 1 college is very good to have. If you are good, if your grade score is good and you end up in a tier 1 college, it will be awesome. Because in tier 1 colleges like IITs and NITs and triple ITs, the atmosphere is like that. You will end up knowing each other very well. The peers are competitive. Professors are competitive. College itself is an environment where you can build up a good network. Alumni will be very good. So try and get into the tier 1 college if you can. Then other thing is on LinkedIn, on Facebook, Instagram. If you like any domain, follow that pages. So you will get to know the technologies, innovations, and the news that every day coming into that field. You can stay tuned and updated with that. So one of the question Nihar has asked that what is the salaries in IT and computer industry? I would say you will not be able to spend. You will end up saving some amount of it, some amount of it. So you don't worry about salaries. Salaries will be good if you are having a good domain knowledge and if your skill set is good. Which language are important among C++, Python, or Java? So this question is like it depends on the requirements. C++, as Paras has mentioned earlier, that every domain has its own advantages. So C++ is good in graphics. Python is all-rounder. Python can do it in anywhere. Java is good in web development, Android development, things like that. So types of question asked in placement. So as I mentioned, everything can be asked in any place. So all the core subjects you have to study, and you have to prepare for the core subjects, and then those are the questions which will get asked. It will be always a basic question, because at the end of the day, they also don't want to spend the time by asking some rubbish questions, and they will let you know their interest beforehand. So this was the point that I am making, that you should be active in your community. Paras, would you like to add few more points?
Yeah, thank you, Shivang, for giving the insights that what would be, what would it take to build your networking skills, right? So you can also opt for certain freelance platforms that are there. So if you are good at something, let's say you are just good at making whiteboard animation videos, right? Or let's say you are good at making certain dynamic websites or certain static websites, right? So you can post your profile into Fiverr, freelancer.com. All those platforms have many customers who will require very small work needed to be done for them. So it would not be a big work, but you will get exposure in getting small things done. And the good thing is you will be paid for that, right? So you can also showcase a certain freelance work in your profile, because that will show that you are a person who is able to work independently without having the support of the resources that are available generally in any multinational company, right? So that gives a very good point for the recruiter that you are a self-learner, right? The other thing is that you can also search for non-profit work. So you can also opt in for something like Free Code Camp, right? You can follow them. they have many resources where you can choose for a non-profit work that is available that you can choose and work on, right? If you solve those non-profit problems, you can all again boost your profile by mentioning that you did certain thing, or you enhanced some code capability for certain non-profit organizations, right? And uh, that is what pretty much covers all the part that I wanted to explain regarding the networking in IT domain. Sagar will take you through what would be the specific points that he has for the VLSI field, because it differs there, because VLSI networking would be somewhat different compared to IT sector. So yeah, Sagar will take it through.
Thanks, Paras. Yeah, he's right. Absolutely, that there is a vast difference in how you connect in the VLSI field compared to the IT field. So for VLSI field, what I would recommend is you start writing your small codes and blogs on whatever you learn, and then share it with your friends, colleagues, whatever, wherever and whatever you are. You go to different EDA conferences, which happens every year. So I work in one of the EDA company, Mentor Graphics. There are other conferences from Synopsys and companies like Cadence, Qualcomm, Intel, who keeps their conference every year. Go there, meet a lot of industry people, have your network more and more profounding and sound. Apart from that, what you can do is present papers at IEEE, go to IEEE conference, write papers on any topic which you like on the VLSI side. Say for example, one of the viewers watching right now is asking on the power side. He can write a paper on the power technologies which are there in the market and contribute there. So the basic idea is just go to the conference, write your own paper. Once you come to the industry, you go and present papers on the various work and researches you have done in the DVCon, VCAD, etc. And apart from that, for the freshers, those who are looking for that, there are specific course there in the market. My organization, Mentor Graphics, currently works with the final year students and train them on System Verilog and UVM. So you can connect to those guys who are working in the CAD industry. They will allow freshers or those who are in the last semester of their graduates, they can conduct the trainings by showing their grades. So that's it from my end. So I will now switch to Jaspal. Will give you a good idea of how to build your resume very catchy and can land up in many interviews. Over to you, Jaspal.
Yeah, thank you, Sagar. A resume is actually the first impression that you put. Actually, nobody is going to personally meet you. It's your resume that's going to be visible to the outside world. So it's very important that you have a good resume. So what's a good resume? How do we start with that? So first of all, the world of internet, you will find the n number of resume samples for each of the profile, each of the domain. So you, whatever the domain you are applying for or whatever the profile you are applying for, you should only search for those profiles and the domains into the internet and see the sample, see the content, see the segregation that has been made, see the sequence, what sort of things are kept first or what sort of things are kept last. Now, one more thing to add to this is like resumes for the same profile or for the same technology are different at the different experience levels. So suppose you are, I'll assume that we are preparing a resume of a fresher. So for that particular point also you should take into the consideration while when you are building your resume, right? So the one more important, so this was the first thing. I better rather prefer you people to just note it down the keywords so that next time when you are preparing your resume, you will these points will be handy actually. So one next thing is like you only put down the things that you know. So why I'm telling this is because when the interviewer will just go through your resume and he'll keep asking the question from that itself. So don't overwhelm there actually. So if you will put the latest technologies there, or you will prepare a handsome resume, okay, so you might get shortlist everywhere, but you will be rejected from everywhere. Like shortlist तो हो जाओगे हर जगह, but reject भी हो जाओगे. So that shouldn't be the case. So another thing to take care while resume building is keep it crisp. Don't put much detail in that. Again, for the freshers, I would not emphasize on putting too much things in the resume. Okay, yeah, that's something about the resume building. Now I'll hand over to the Paras for further update on resume building.
Yeah, thanks, Jaspal. So, adding to what Jaspal just mentioned, right? So it is very necessary for you to, after building a good resume, right? You should, always get it peer reviewed. So many other times, what we see is that resumes have basic grammatical, basic spelling mistakes, right? So that should be avoided at any cost. You take however much people you want to get it reviewed to, but those type of mistakes can be eliminated from the start point itself. And there is a difference in creating a very elaborated resume and creating a very short resume, right? So the point is that don't mention too many details, as Paji mentioned, right? So if you mention too many details, what happens is that the person wouldn't be able to grasp each and everything out of it, and he will simply check the resume, right? And the other point that I want to mention in resume writing is that you should cite your Git links. Please do that. If you have done any open source contribution, if you have done any if your Stack Overflow profile or if your GitHub profile is powerful, you should cite that in resume. You should showcase your work. You should mention them as projects. You should show that, because you are at the entry level, so it will give you the it will give the recruiter a fair amount of idea that what you have worked on, what you have achieved in the past, right? Rather than just mentioning your scores in a university exam, you should do this. This should be of prime importance in your profile. And as I told, right, there is as Paji mentioned, you should not lie on your resume. So there is a fine balance, fine balance that you have to maintain. You shouldn't, adjust your resume as per the job description. Rather than you should just mention what you know about, so that whenever you are asked that question in the interview, right, you don't get you basically increase your chances by mentioning or being honest to yourself that what you know about particular technology. So it is very necessary that you don't mention something which you don't know. So uh, moving from here, after just imagining the scenario that you have ended up getting a very good interview opportunity, Harsh will take you through that. What are the do's and don'ts that you should do, or you should take into consideration while doing the prep for the interview. Harsh, over to you.
Thanks, Paras. So I know we are running a little over the time, and we are really, really short of it. So I'll just go through the highlights of what things need to be done in the interview. So first and foremost, confidence is the key. You have to be very confident when you enter the room. You have to be very confident while talking to the interviewer, and while giving the answers as well. And make sure that you will be tested in all the ways. So you have to be at your best behavior, best mindset when you go for the interview, and you should be ready for all the explanations that you have on your resume. And as well as the one most common question that you will find in any interview is tell me something about yourself. So I would suggest just, if not script it, at least try to rehearse that answer to that question by yourself, and see if you can put all the necessary details into that question, so that the interviewer feels that okay, you can be the right person for the job, and they can build the interview on top of what you say. um, General process of interview would be either 2 or 3 stages. First process might be a screening process, in which you might be asked to have some go through some written test, and if you pass that, then you will be going through the technical rounds, and then towards if you pass all the technical rounds, you will be again called for the managerial round or the HR round. But make sure depending on the company, the technical rounds could be in a single day, maybe from the morning to evening, or it could be be over multiple days as well. So it again depends on how the companies are recruiting. Make sure you don't hurry too much into answering the questions. You will be given enough time in the interview. Don't haste. Be calm and try to grasp yourself and answer very with the full confidence. And interview is a two-step process. It's not that only the interviewer will ask you the question, you are also allowed to ask the question to the interviewer about what all things they are working on. If you're joining the company, what will be your role, what will be your position, how much or what kind of work you will be working on. So it's a two-way process. So you should be asking interviewers also the questions that you are concerned about. I think those are the highlights of the interviewing process. As we're running short of time, we'll just move on to the next topic of having some corporate etiquettes. Sagar, would you like to add something here?
Yes, sir. Thank you again. So corporate etiquettes, I guess it's the most important thing once you are entering in the corporate lifestyle and once you want to have a career in the IT or the semiconductor industry. So the basic idea is to have the etiquettes profound and much needed for your industry standards. So the what you should do is you should first start with your body language. It should be sound, neat, clean. You should dress appropriately. Don't be late to office or meetings. If you have any phone calls, go and take in the private rooms once you go into the field or while you are giving into going to the interview. First listen, process, and then respond properly. Be a good team player. Take initiatives. Be a good leader. Like if you are given a task, you should not back out and say I will not do. Initially, take every task whatever is given to you. Reply promptly to email and instant messages, and review the email twice before sending, because that's where you will create a mess if you don't do it properly. So yeah, those are very small but very much needed office etiquettes which everyone should have. So yes, that's what all I have on the office etiquettes. I would now go and ahead and proceed to Pratik, who can talk about more on the core interest on the technical side if he has. Pratik, over to you.
Okay, thank you, Sagar, for explaining this. So I would like to keep this discussion very short. So the finding your tech interest in the means like some people have the interest from the starting itself. Like Mansi talk about she was interested in the VLSI and she started focusing from the that domain only itself. And I have an interest in the embedded and I also start focusing on the same field from the starting itself. So don't lose your focus. Like if you found you heard somewhere this domain has more opportunity and everything, so that is not the like the thing. You just keep focus on your particular interest and you will find the good job in that. So I just want to talk about my failures to sticking with the interest. Like when I was doing the embedded job, embedded training in the vector, like some of the companies I have skipped, which is the IT related, and due to that I get the chance into going into industries late. But finally I found a very good job which I like on the device level and which I have explained what I have done in that. So, and some people don't have, like some people have feel hard time to finding their interest, what they need to do or that thing. So on over that, Jaspal will tell you some of 2 or 3 lines. Like he will explain you what to do in those cases.
Yeah. So in the elementary stage, actually, suppose you are not able to find any of the interest. So in the initial time, what you can do is you can keep involve yourself in the activities which are going around. That could be a technical or non-technical. So keep trying all the things, and later you may explore that this is my interest. So this is nothing but treasuring, hunting your interest. Actually, that's the one thing. So by this I mean to say that there will be people who will be saying that what if I am not able to understand what's my interest, or something like I have tried some few things and now I'm not able to find the interest. But it is very important to find the interest. So the key is like you keep trying the things, and you may end up finding your interest. There are a few examples on that also. So one of I know a few people who actually found their interest from nowhere, and now they are professionals in that field. So just give a try. Don't just waste the time saying that I don't have any interest and I'm not able to find the interest. Without trying, nothing can happen. Yeah, that's all for this finding the interest section. We can
Thank
move
you so
forward to
much.
the next section.
Thank you so
Yeah.
much, Jaspal. So we are running really short of time, and I would like to conclude here. To all the students who are watching live right now and who will be watching it later, guys, make sure you. I mean, don't worry at all. You will be facing failures every now and then. Interviews might be cracked successfully. Some might be just a blunder. You might be selected somewhere, might not be selected somewhere, but make sure you keep trying. You never quit. That is the whole and sole purpose of having these conversations, that okay, you keep trying, we are here to help you. And at the end of this in the description of this video, we'll be adding email IDs and the LinkedIn profiles for everyone that you saw on this live telecast, and you can contact any of them based on your specific questions or any doubts or any help that you need. And I mean, pretty much that's more or less all we have for you now, right now. Hopefully, we'll be able to meet again and have another session specific to any other topic that you would like to know, or maybe some other webinars that you would like to know. Please make sure you subscribe to this channel and hit the bell icon to get the notification for the more and more such content that you'll be seeing further. And yeah, keep hustling, keep trying, never quit, and you'll be succeed sooner than you know. Thank you so much.
Thanks, guys. Thanks, everyone.
Bye bye.
Bye bye.
Thank you, guys. Bye.
Bye, guys. Thank you for joining.